In the last few videos, you learned how to create and use short-lived processes to do work concurrently, but here's the thing. There's another type of process that you'll often use, which I'll call a long-lived process. So what exactly do I mean by long-lived process? Well, these are processes that run for indefinite periods of time, such as hours, days, months, or even longer. So why would you want to use a long-running process? I mean, what are they good for? Well, let me give you an example of a long-running process that we'll use a little bit later, which is a long-running process that maintains a connection with the database. Database connections are somewhat expensive in that it takes a significant amount of time to create a connection, and each connection to the database takes quite a bit of memory, and you really don't want to allow too many connections to a database, or it'll bog down your database server. Now, typically, to work around the challenges and constraints associated with database connections, a limited pool of database connections is created and maintained, and individual connections from a pool are then used as needed. There's a common characteristic to pretty much all long-lived processes, which is that long-lived processes typically have state. So, for example, a long-lived process for maintaining a database connection has some state that's related to the database connection. So far in this course, we've largely avoided state with one exception. Do you recall the one time we dealt with state in this course thus far? It was when we created our first app, the terminal-based vote counting app. The state we maintained, in part, included the name of the election, the candidates in the election, and the number of votes each candidate received. Do you remember how we were able to maintain state in that application? When we created the app, I showed you how to maintain state, but I didn't really spend a lot of time talking about state, mostly because we hadn't talked about processes yet, and you can't truly understand state in Elixir without understanding what processes are and how they work. So here's the deal. When you need to maintain state in Elixir, one of the primary options you have is to create a long-lived process. Okay, so how do you create a long-lived process, and how would you update and maintain state in a long-lived process? For example, let's just say I wanted to make a process that maintains a count, just a simple integer that starts at some value and can be incremented or decremented. I'm going to create a module named counter, and inside the counter module, I'll create a function named run, which takes a count, and for now, I'll just return the count. Before we continue, let me ask you a seemingly simple question about the run function. What are the possible inputs and outputs to the run function? The keyword there being possible. Okay, you might be thinking, James, that's a pretty dumb question. Well, obviously in this case, the explicit input is the count parameter, and the explicit output is the count return value. But really what I'm asking is, are there any other possible inputs and outputs for the run function? Okay, obviously since I'm asking this leading question, there must be. So do you know what they are? You've already seen them, but you may not have realized that these two things offer what I'll call alternative inputs and outputs. So what am I referring to? Well, you could use the receive macro in the run function, which is another way for the run function to receive input. Additionally, you could use the send function within the run function, which provides another way to do output. So basically, every function in Elixir has explicit inputs and outputs, which are the parameters and return value, but they can also have alternate inputs and outputs via send and receive, which can be summed up as message passing. Keep these alternative inputs and outputs in mind as we think about how to create a long-lived process. I'm going to open up IEX with the script file where I created the counter module. Now, I've showed you how to spawn processes by calling either spawn or spawn link and passing in either an anonymous function, or in the case of named functions, you'll pass in the module name, the function name as an atom, and a list of arguments. What's returned from spawn link is a PID for the newly created process. If I check to see if the process we just spawned is alive, well, it's not. The run function was called once in the spawn process, and then the function returned, and the process had nothing else to do, so it died. The bottom line is, the run function, as it's currently implemented, won't create a long-lived process. So the question is, how do we turn the run function into a function that can be used to create a long-lived process that can actually maintain the count? Here's the key to making a long-lived process. The function that the process runs can't end. So how could we make the run function never end? Well, what if instead of returning the count here, we instead pass the count into another call to the run function? Now, I'm pretty sure many of you are thinking, James, what you're doing right here is a really bad idea. You've just created an instance of infinite recursion, which is sort of like an infinite loop. Okay, yeah, it would be a bad idea if I told you we were done, but we're not done yet, so hang with me. Now, what I did here in the run function basically causes the run function to run indefinitely. So if we spawned a process with the run function, the process would be long-lived, though at this point, the process wouldn't be useful. In fact, it would be harmful to the server because it would peg one of the server's CPUs as it indefinitely recurses. So let me ask you this. What can we do to the run function to interrupt the infinite recursion and make the run function useful in a process? Well, what if we added the receive macro to the run function? By doing this, we get an opportunity to interrupt the infinite recursion because the receive macro will block and wait for a message. So what kind of messages should we be checking for in the receive macro? Well, think about the goal right now, which is to create a process that maintains a simple count. In other words, we'd like to initialize the count to some value, then we'd like to either increment or decrement the count as needed. The key functionality here is incrementing and decrementing a number, so to accomplish these two things, the process that is running this function should be able to receive an increment message, which I'll say should be an atom, and when this message is received, we should just take the current count and add 1 to it. Additionally, we should be able to receive a decrement message, which just takes the current count and subtracts 1. So this receive macro is going to block until it gets one of these two messages. Then when it does get one of these two messages, it's going to either return an incremented or decremented number. So what should we do to the number that's returned from this expression? Well, whatever number is returned from this expression is the new state for this process. So why don't we just get rid of this line, which has the old count, and we'll just pipe the updated count value into the run function. Okay, what I just did here is very noteworthy. I just showed you how to maintain state in a process. You do it by passing a new state into a recursive function call. We've done this before in the vote counter app, but again, at the time, I didn't fully describe everything that was happening. I'm going to add one more bit of code between the receive macro and the run function. I'll log the count using ioinspect, and I'll label the count. This way we can see the number as it's incremented and decremented. Let's try using our run function in a new process. So I'll fire up IEX again with the file that contains the counter module. Then I'll create a PID variable, and I'll bind it to the value returned by calling spawn link, and I'll pass in our module name, counter, followed by our function name as an atom, run. And lastly, I'll pass in a list that includes the parameters needed for the run function, which in this case will be the initial count, which I'll just say is 100. Now I'll go ahead and send this new process a message, the increment message. And as you can see here, the count was increased. If I send the increment message again, you see the number goes up again. Now I'll send the decrement message, and you see the number go down. Cool, it worked. What do you think will happen if I send the process the message double? Let's try it and see. Okay, well, it didn't seem to do anything really, and this is a problem. What actually happened here is the double message went to the process mailbox, and it's just sitting there because the receive macro isn't checking for and dealing with double messages. In fact, if you open up the observer, and we find the process ID we see here on the Processes tab. Then if I double-click on the process and look at the messages, we see the double message just sitting there. So a moment ago, I said this was a problem, but I didn't really say why it's a problem. Do you have any thoughts on why this is a problem? Well, it's a problem because it's sort of like a memory leak. For example, if I keep sending the double message, more and more messages accumulate in the mailbox, and the memory that's used for the messages is never released. So what should we do about this? Well, we could add another pattern match in the receive macro that will capture any message that isn't the increment or decrement message. Then I'll just inspect the message, giving it a label of unknown message, and lastly I'll just return the count unchanged. By adding this line, we're ensuring that every message this process receives is pulled out of the mailbox, so we avoid what would essentially be a memory leak. Okay, what we did in this video sort of worked, but the counter module in its current state isn't very pleasant to work with, and it doesn't have all the functionality you'd probably want. Here's what I mean. To use the counter module, we've got to call spawn like this, which is rather verbose and could be hard to remember. Additionally, we've got to send messages like this, which means we've got to remember what type of messages are valid and hopefully avoid misspelling the message names. I think we can improve on what we started here, and that's what we'll work on in the next video.